Okay, I just wanted to address the graphical addition of vectors because a lot of you on that lab just didn't do it right. I just want to make sure that we're doing it right because it will be on the midterm. I will have you graphically add vectors where we have to do the following. So in the lab, you had two vectors. You had that we had three vectors. A was equal to 0.75 newtons. You had that B was equal to 1.5 newtons. All right, we had a C too, we'll get back to that. So we had these two vectors, and then you had to create a scale. So imagine that you have this sheet of paper. It's about, I don't know, 20 centimeters on the side, so it's approximately 20 centimeters on this side. And I want to create a scale so that these vectors, when I draw them, will fit on that sheet of paper. Oh, by the way, the angle for this vector was 0 degrees, and the angle for this vector was 60 degrees. So our first job then is to figure out what is a scale so that I can get these vectors drawn in such that they fit across most of the page. Because I want nice big vectors because it'll just be easier to measure when they're bigger, to measure the angles and to measure the lengths. I'll be looking for that on the exam too, by the way, next week. Turns out that scale, well, I can sort of sketch out the vectors. I'm just going to sketch them out here. I have one vector that'll be like that, and then another vector will be twice as long at an angle of 60 degrees. But I want to draw that to scale properly on the paper. So um, some of you used 1 centimeter was equal to 2 newtons, I think. I forget what the scale was. You used whatever was given in the example in the workbook. But it turns out actually that the better scale is to say that 1 newton is equal to 1 centimeter is equal to 0.1 newtons. When I have that, that means that vector A, which is 0.75 newtons, I can do this conversion factor, 0.1, 1 centimeter, zero point 0.1 newtons, that it comes out to be 7.5 centimeters long. And then in a similar way, that my 1.5 newtons will now equal to 15 centimeters long. So when I draw these vectors, I'm going to draw this vector as 7.5 centimeters, and then this vector as 15 centimeters. And in drawing them in that way, it'll cover most of the page. So now I'll use my ruler, and I'll measure the length of that first vector to make it 7.5 centimeters. Let me make it a little bit longer than that. I'm not using a ruler right now, but you would use a ruler, uh, 7.5 centimeters. So this is 7.5 centimeters, which is equivalent to 0.75 newtons. Then I would use my protractor to measure this angle equal to 60 degrees. Use my protractor to measure that angle, and then I would draw this vector. It's going to be twice the length of the original vector, or 15 centimeters. That's equal to 1.5 newtons. Then I can come along and I can draw my resultant vector. I can start here and draw my vector so that it goes from the beginning to the end, and I can measure this angle theta, which y'all calculated that angle to be about 40 degrees, and you should get close to 40 degrees when you do the graphical analysis. And then further, I should find that this vector is about 20 centimeters long, and then I can convert that back to 20 centimeters back to newtons using my scale right here. I'd have 1 centimeter, zero point 0.1 newtons now, and so that's equal to 2 newtons, which you found that to be the case, that the magnitude of the vector r was 2 newtons long. Okay, so that's what part A should be. In the second part, where you're doing the S equal A plus B plus C, you're going to want to do your paper in portrait like this. I'm going to sort of sketch it out. I have A and then B twice as long. And then the vector C I know is in the negative direction. So it's going to look roughly like that. Now that won't fit on a paper that's oriented portrait or landscape. So you have to do it portrait. Using the same scale, we can still use the same scale that 1 centimeter is equivalent to 0.1 newtons. Remember on these, this one was 0.75 newtons. This was 1.5 newtons, and then this is 2 newtons. So they're going to be 7.5 centimeters, 15 centimeters, and then 20 centimeters. So then I can go and draw the vectors using my ruler, measure a line that is 7.5 centimeters long, measure a line at 60 degrees that is twice that, or 15 centimeters long, and then measure a line that's in the downward y direction that is 20 centimeters. This is the vector A, this is the vector B, and then this is the vector C. Again, this one is 7.5 centimeters, this one is 15 centimeters, and this one is 20 centimeters long using this scale. Next, I want to do like I did before, draw the resultant. The resultant is right there, beginning at the beginning of A and ending at the point where C ends. I can measure this angle, and I find that that angle is about 25 degrees, uh, 25 degrees below the x-axis. My x-axis is right here. And then I find that the length of this vector is about 1 point, well, you found it to be about 1.7 newtons. Okay, that means that the length of that vector is going to be 17 centimeters. So you measure the length of that vector with your ruler and find it to be 17 centimeters, and then you can convert that back into newtons. 17 centimeters, 1 centimeter, zero point 0.1 newtons. That's going to be 1.7 newtons. Okay, so we measure the length of the line to be 17 centimeters. We measure the angle with our protractor to be 25 degrees, and then we can find the magnitude of that vector by converting using our scale. Now there was one other part to this. I'm going to show it easier here. Where you had to find the x and y components. I can find, if this is vector r, I can find the x component simply by dropping a line down to the x-axis and then measuring the length of that vector. That's going to be Rx. Rx you found to be about 15 centimeters long. So it's going to be equal to 1.5 newtons. And then I drop a line over on the y-axis, and this is going to be Ry. You find Ry to be about 13 centimeters. 13 centimeters is equivalent to 1.3 newtons. So those are the x and the y components. You could do likewise. I think you had to do this. Did you have to do this? No, I don't think you had to do it. Never mind. But you could find the x and y components. And I might ask you to do that on the exam too. On the exam, I'll likely just give you two vectors, and I'll ask you to graphically add the vectors. I'll be looking for an appropriate scale right here. I'll be looking that you measure the angle properly and draw the vectors with the correct length per your scale, and then that you're also able to find the resultant vector and the angle and the x and the y components. So I will be asking that for certain because it did not go very well in the lab, and you know, partly that's because we didn't do it in class, but also I just want to make sure that we're on the same page on how to add these vectors graphically. As always, I'm available. If you need help or if you just feel really confused about this, then please come see me. Also, you know, there's tutors in the tutoring center. They know how to do this. They've done this. They've done it really well. Those tutors, I know them personally, and they're very good in this class. So I encourage you to, well, to take those steps. It'll be important, okay? It'll probably be about a fifth of your overall exam. Yeah, about a fifth of your overall exam, which is next week. Next week is our exam. Okay? All right, y'all. Have a good day.